Finally, in this section, we're going to look at complex fractions. They're not rational expressions, but they're related in terms of the way you simplify them. And so let's first of all take an example with just numbers. A complex fraction is any fraction that has a fraction in either the numerator or denominator or both. This fraction happens, here's our fraction bar. Of course, we have two others. This fraction happens to have a fraction in both the numerator and denominator. The method for simplifying these that I recommend is, first of all, looking at the denominators of your fractions you have here, 6 and 20, and finding a common denominator. So let's do that. If we take 6, the prime factors would be 2 and 3. If we take 20, the prime factors would be, let's see, 2. 20 is 2 times 10. 10 has a factor of 2 and 5. So there are the prime factors. Let's find the common denominator. It would be, we take 1, 2. No, actually we need 2 2's because here there are 2 of them. We're going to have 1, 3 and 1, 5. So if you multiply that out, you get 4 times 3 is 12, times 5 is 60. So 60 would be your common denominator here. Okay, once you find that common denominator, the method is to multiply both the numerator of this entire fraction by 60, both in the numerator and in the denominator. So I'm going to multiply by 60 over 60. If I multiply this fraction by a common denominator for it, it will no longer be a fraction. And the same is true down there. That's why we chose 60. It'll work for both fractions. Remember, when you multiply a fraction by a number like 60, it's the same as multiplying by 60 over 1. Just so you can line up the numerators and denominators. 60 over 1. Okay, and of course this is equal to 1, that's equal to 1. I'm just going to make it look different. I'm not actually changing the value of this complex fraction. So let's see how this works out. Here I'm going to get 5 times 60, and I'm not going to use factors, but I'll get 300 over 6 on the top. On the bottom I'm going to get 180 over 20. And what you'll find in these cases is that the fraction you end up with here will simplify to something that's not a fraction. 300 divided by 6 is 50, so I get 50 over 180 divided by 20 is 9, so you get 50 over 9. And I believe that's simplified because 50 and 9 don't have any common factors. So that would be with numbers. Let's do the same thing with the algebraic expressions. This is even a little more involved because it's got the minus here, plus down here, so it's not a simple fraction in the numerator and denominator. We're actually subtracting 2 fractions and adding 2 down here. But the method is the same. Look at the denominator of every fraction involved. The denominator of this fraction is x. The denominator of that one is 2. And, I mean, they don't have any other factors, so they're already, here's another one with x. Here's 4. 4 has factors of 2 and 2. So when you're finding a common denominator, we're going to need 2 2's. We're not going to add anything with that, and 1x, taking all the factors that are in the denominators, and you'll end up with 4x. Okay, the magic part of this is, it's not magic, but what seems to be magic is if I multiply the numerator by 4x and the denominator by 4x, we will no longer end up with fractions up here or down here. So let's do that. And again, if you feel more comfortable, you can put the 4x over 1, 4x over 1. You multiply. And also another thing to remember, the fraction bar is a grouping symbol, so you could put parentheses around that to remind yourself that you have to multiply it by both terms. We'll use the distributive property on that now, the same here. So if you multiply here, 4x over 1 by 1 over x, and the numerator is going to end up with 4x, and the denominator just x. If I I multiply it by, you're going to have minus 3. 4x times 3, you'll get 12x here. In the denominator, 2 times 1 is 2. So we get that. Down here, if we take this and multiply it by the first term, again, I'm going to get 4x over x. Then we're going to have plus 4x times 3 gives me 12x again, but it'll be over 4 times 1, or 4. Okay. Normally, this method, it doesn't look like we're getting anywhere, because this certainly is not any simpler than this original problem, but we're going to get to a simpler situation quickly here. 4x over x, if you simplify that, you know that we can factor out an x from the numerator and denominator and just end up with a 4. If we look at this fraction, we have 12 over 2. This, if we divide those out, we'll have a 6 left. So this simplifies, and we'll have an x. So that simplifies to 6x. In the denominator, this again, the x's will cancel out. We'll be left with a 4. And then we'll have plus, if we simplify this, 12x over 4 will simplify just to 3x. Okay? Looks like the numerator we could factor, denominator we can't, so that should be as far as we can go. But this fraction, again, is equivalent to this one, except it doesn't have complex fractions anymore. But you do need to carry restrictions along. So it is going to be the same as that fraction, but we need to remember that we can't divide by 0, so x can't be equal to 0. And 1 over x can't be equal to negative 3/4, so that would lead to another restriction. But this is mainly what I want you to be able to find, is this, be able to express these complex fractions as simple fractions.